complex numbers, example 13. We've got two complex numbers here, W and Z. They do tend to call the second one, if you've got more than one, they either call them Z1 and Z2, or they do sometimes use the letters Z and W. We've got to first of all write each of these in modulus argument form. So remember, that's R cos theta plus I sine theta. So we need to find the modulus and we need to find the argument of each one. So the first one's pretty straightforward. The modulus of W, well, it's 10i, that means 10 vertically upwards, so its modulus is just 10. And then the argument of W, well, if it's vertically upwards, 10i, if you imagine it sort of plotted on some axes, 10i would be up here, and so that means we've got an angle of 90 degrees, which we'd write as pi over 2. The next one is 1 plus root 3i, so it's 1 along and root 3 up. 1 along, root 3 up, so it's in the first quadrant, so it's easy to work out the answer. So the modulus of z will be, now we've got to square each side, so the square of root 3 is 3, and the square of 1 is 1. So it's root 4, which is obviously just 2. And then the argument of z is straightforward, it's just this angle here. It's the inverse tan of root 3 over 1. Now, when you've done the trigonometry section of C2, you will know what the inverse tan of root 3 is because you will learn them all. It's a standard angle, it's actually 60 degrees. Inverse tan of root 3 is 60 degrees, and in radians that's pi over 3. So we've got to write them in mod arg form. So W is 10 cos pi over 2 plus I sine pi over 2. And if you have time in an exam, quickly times it out and check that it gets you back to what you started with. Z is 2 cos pi over 3 plus I sine pi over 3. So that's part A done, part 1, sorry, and then part 2 asks us to find the modulus of WZ. Now what you could do is multiply W and Z together and then find the modulus, but that's quite lengthy, and if you remember in the little introduction on page 8 to this section, there's a rule that says if you times the numbers together and find the modulus, it's the same as doing it the other way around, finding the modulus and then timesing them together. So modulus of W times modulus of Z, so that saves us a bit of work. The answer is 20. Similarly, when we do the division, same thing applies, and if you look back at page 8 in your notes, you'll see the same rule for division. It's modulus of W over modulus of Z, so that will be 10 over 2, which is 5.